fits that series, and then we're going to apply the test.
And that's in the modules, right?
That's in files, under files. Yeah. All right, some notation and language, just so that we're clear. I've already said that an infinite series is this, right? That's the notation for it. What I have not explicitly stated is what is called the nth partial sum of an infinite series. So let's say somebody gives us an infinite series, all right? Someone gives us an infinite series. But we don't want to add up all of them. We only want to add up n of them, the first n. Okay? Then we call that the nth partial sum. Okay? We're just adding up the first n. And here's the notation for it. I'm going to make this huge for you. The notation for the nth partial sum is capital S sub n. That tells you, hey, we're adding up just the first n. And notice how the notation changes right here. I change my index. I start at k instead of n. I start at k equals 1. And where do I stop? When I get to n. And so then the sequence formula becomes a sub k. And so the first thing I do is I replace k with 1, and that would be a sub 1. Then I add to it, and I let k be 2, that's a sub 2. And then a sub 3. Until I get to where? A sub n. That would be adding up the first n terms of the series, right? Adding up the first n terms, we call it the nth partial sum. It's not the whole sum, it's only the sum of the first n, okay? So that is just a finite sum, right? That's just a finite sum. So to clarify what those sums are, S sub 1 would mean just add up the first one, right? S sub 2 would mean you're adding up the first 2. S sub 3 is the first 3. S sub 4 is the first 4. And so on and so forth. S sub n is the first n being added up. Yes? Okay, now here's the big thing, the big connection you have to make. S sub 1, S sub 2, S sub 3, S sub 4, those are just numbers, aren't they? S sub 1 is some number, right? It's actually just A1. But what's S sub 2? It's the first 2 added up. Well, is that going to be a number? Yes. S sub 3 is the first 3 added up. Is that going to be a number? S sub 4 is going to be a number, right? All of those will be numbers. Isn't that a new sequence of numbers? Isn't S sub 1, S sub 2, S sub 3, S sub 4, isn't that just a new sequence? Not the original sequence, a new sequence. And that sequence, S sub 1, S sub 2, can be written out, right? Like a list of numbers. The question is whether or not that sequence converges, that sequence S sub n. Does that new sequence converge or not? Well, how do we figure out if a sequence converges? We take the limit, right? We take the limit. We take the limit and figure out if it converges. If that limit exists, okay, if we take the limit of the sequence, of the new sequence, if we get an answer, then we will say the infinite series converges. If we don't get an answer, or something like infinity or doesn't exist, we will say the series diverges. And this is the way we'll write it, okay? It's in bold here because that's important. That sum of the original series, capital S, will be the limit of that new sequence, if it exists. Okay. So let's go back to, let's do this one right here. All right. This right here, this is the original sequence, right? 1 over n. Now, this right here is actually what I'm talking about here. This first number is S sub 1, isn't it? It's the adding up the first one. This is S sub 2. That's the first 2. S sub 3 is this one, right? And then S sub 4 is this one. So if I were to write out that sequence, this new sequence, the new sequence is 1, 1.5, 1.833, right? Let's see. And then it keeps going, doesn't it? This sequence right here is S sub n. The question is, do you know the formula for it? Do you know the formula that gave us these numbers? 1 over n, right? But do you know the formula that gives you those numbers? No, and it's not easy to find. If we could find it, right? If we could find it, then all I do is take the limit of it and get an answer. But the problem is finding this is freaking hard, okay? This is really hard to do. It's really hard to find a formula for S sub n in general. Some series we can do it, some we can't. Most we can't, all right? All right, any questions? You need to see, because the problem I see in this is students will be saying sequence when they mean series and not knowing what they're talking about. This is the chance to understand like the words and any questions over anything. Or do you feel like you don't know what to ask? All right.
Could you define exactly what you mean by between series and sequence? Like just like actual like straight definition.
Sequence is a list of numbers given to you by a formula. A series is the sum of those.
Okay.
That's it.
Same question.
The same question, yeah. Sequence is just a list of numbers. This is a sequence right here. This is a sequence, right? Because it's just a list of numbers. A series is when you add those up. All right, so I put here it's difficult to do this, right? If we could do it, if we could, we just take the limit, we'd be done. All right, I say let's clarify. Let's see what I want to clarify. Partial sums. Yeah, this is everything I just said. So we try and come up with this formula if we can. If it converges, then we have an answer. Otherwise, we say it's divergent. Okay, so now we are ready for our first test. You ready? You have all those tests on that sheet of paper, right? What's the very first one at the top? What does it say? The nth term test. That's the very first test that we have. And this is the test that I recommend you do, okay? When you are trying to figure out whether or not a series converges or diverges, that you run this test first. So let's see what the nth term test says. All right? It's called the nth term test. It's also called the test for divergence. The test for divergence. The nth term test. Okay, remember, we are talking about series right now, not sequences. We're talking about series. And this is a test for whether or not that series diverges. It is a test for divergence, or called the nth term test. Now let's see what the nth term test says. It's a simple test. Very, very simple test. Here's the test right here. If somebody gives you a series, right? There's the series right there. They give you the series. What you're going to do is you're going to take a look at the sequence that generates that series. The sequence is the A sub n. It's that formula in the sigma notation. You're going to take a look at that, and what you're going to do is take the limit as n goes to infinity. You're going to take the limit of the sequence. And if it goes to something other than 0, you can tell me the series diverges. All right, we're just going to do an example. So what if I ask you this? Does this converge or diverge? And from now on, instead of writing that, you'll see me write C or D. Okay, converge or diverge, so I don't have to write those words over and over. Okay, does this converge or diverge? Here it is. Let's do the first example we had. Sum n equals 1 to infinity of n. All right, how many tests have we learned? 1. The only test we have is this one, right? And this test only tests to see if we have divergence. What I'm going to do is I'm going to look at the formula that is in here, right? This right here is my A sub n. And I'm going to run this test. I'm now going to tell you what I'm about to do. I'm going to do the nth term test. See how I'm letting you know what I'm about to do? The nth term test. I'm going to take the limit as n goes to infinity of that sequence, n, and see what I get. Well, what do we get? We already know this answer. We did it a second ago. What is that? Infinity. And what you can tell me is infinity is not what? 0. And the nth term test says that if you are looking at a series and you take that little formula and you take the limit and you get something other than 0, which we're getting, right? Something other than 0, what can you tell me? What diverges? The series diverges. Okay? So this limit goes to something other than 0. Therefore, I've used those 3 dots, yes or no? Yes? Therefore, what? Draw your conclusion. The series, what? Diverges. That's it. You're done. If the sequence goes to something other than 0, the series diverges. And we're done. Let's do this one. All right, so for this one, my question is, does this converge or diverge? All right, so I'll rewrite it. So let's try the nth term test, right? That's all we've got right now. Nth term. I'm going to take the limit as n goes to infinity of 1 over n, right? I'm taking the formula in here and I'm taking its limit. And what does that go to? That goes to 0. Okay, very important step right now. The nth term test says that if this limit, what? Doesn't go to 0, it diverges. Well, what if it does go to 0? Because it does, right? It goes to 0. What then? It's inconclusive. The test for divergence only tells you if you have divergence. That's all it ever tells you. And it only tells you that if you get something other than 0 here. If you get 0, you know nothing. And the test fails. All right? This right here means the test fails. And you must move on to another test. All right? Logically, most students, when they do the nth term test first time, they're like, okay, got something other than 0, divergence, great. Oh, we got 0, convergence, no. No. The sequence converges, right? The sequence converges, but that doesn't tell me anything about this, the series. If the sequence converges to 0, that does not mean the series converges, does not. So the way, I got in trouble for this the other day. The way that I've always looked at this is a good old-fashioned pregnancy test, all right? So y'all know how pregnancy tests work? Old school ones. There's like a little window, right? And then you have 2 lines that show up if there's a positive pregnancy. The first line, let's just say, is on the left here. And then they'll have another line, maybe on the right like this. And the red line is telling you whether or not you're pregnant or not, right? And the blue line is called the what? Anyone know? It's called the control. So basically that lets, because you have to urinate on the stick and then the urine goes through. And then this line right here, if it shows up, then that means the urine has gotten to there, right? But you need the urine to get to here to be able to rely on the test. So both lines have to show up. Anyways, the way a pregnancy test works is this would mean you're pregnant, right? So the way we look at this right here is this, and I know this is a terrible analogy, but look, by saying that the limit goes to something other than 0 means that you can definitely say you're pregnant. And I know there's problems in tests, right? But if you see both lines, you can draw a conclusion, can't you? You can draw a conclusion, right? This over here is this happening. This is like you get this. That bread's dead. You either get like nothing in the window, right? Or you get something like this. What if you got those two things? What would you do? What would you do if you got those two things in your window? Go get another test, right? Because this is pretty definitive. Positive, right? Divergence. We've got the red line and you got the blue, right? The control's there as well. That's pretty definitive. You got divergence. This is the scenario where you're like, shit, I got nothing, but that doesn't mean you're not pregnant, but it doesn't mean you are, right? Same with this. This doesn't mean you're pregnant just because there's a red line. You need the control to show up as well, right? What if you got this? Even if you got this, you probably would still do another test, wouldn't you? I mean, this would tell you what, that you're not pregnant? But you better be sure, right? So, all right. So, I don't know. The pregnancy test, that might be 2023. Maybe I shouldn't be using that, but COVID test, yeah, but there's a boring, right? There's more on the line here. It seems like, right? This is 18 years of your life here. So, all right. So, do y'all understand the idea of the divergence test? It only tests for divergence. If you get something other than 0, you can draw a conclusion. If you get 0, you better go get another test, all right? All right, next thing. So I have some examples here. I just did one, but I'm going to do a couple more. So it says here, for you to show that all three of these what? All three what? Series. All three of these series diverge. So for part A, sum n equals 1 to infinity, 5n plus 1 over n plus 2. So the only test I have, right, is the n-term test. So what I'm going to do is take the limit as n goes to infinity of 5n plus 1 over n plus 2. What happens as n goes to infinity there? You get infinity over infinity, right? So you can bring in L'Hopital, but remember from last class that when we're dealing with sequences, you can't use L'Hopital. You have to convert it to a function of x first, right? And then do it, and then get your answer and take it back. Do you remember me talking about that? There was a theorem. Okay, that's what we're supposed to do. But because we don't have time for that, right? We don't have time. We are going to use L'Hopital knowing that really what we're doing is we're changing it to a function of x, doing L'Hopital, and then coming back to the integers. Yes?
Whenever we do an exam, are we expected to put what test we did over top of it?
Yeah, I would recommend that, yes. Because what you're going to see as we go through these tests, the challenging part of this is, first of all, getting the right test and then applying it correctly. Because each test is different. So you have to actually show me, like, because at the end of the day, it's a 50-50 question. It's either converges or diverges, right? That's really what I'm going to be asking for, converge or diverge. You could draw the right conclusion, but have no legitimate work to support it. So first thing you want to do is tell me what test you're using, and then do the test. I'll check to see if you're running the test properly, and then whether or not you can draw the conclusion off of what you've written down. Yes?
Is the series always going to start with n equals 1?
No. For us right now, n equals 1 is where it's going to start, right? But later, that can change. It can be pretty much arbitrary, okay? All right, so now I'm going to do L'Hopital, right? So I'm going to put a little L here, let you know what I'm doing. Limit n goes to infinity. Okay, derivative of the top is 5, derivative of the bottom is 1. So our answer is 5, and what? What can you tell me? Yes, because 5 is what? Not 0, right? And this is getting both lines, right, on the test. This is it. This is conclusive. We've got divergence. Therefore, what? The original series, right, diverges. See how I'm drawing my conclusion here? Right? So I had a series, hold on. I had a series, right? I want to apply the n-term test, so I take the limit of the sequence. I got something other than 0. Therefore, by the theorem, by the actual test, I can conclude that the original series diverges. Yes?
When you're writing your answers, we have to write therefore the original series diverges. Do we have to have where it diverges at, or just diverges?
Okay, so a series either converges or diverges. Converges means this thing adds up to be a number. Divergence means not that. So that means it could be becoming infinite, or it could be doing something like the one we did earlier. I haven't really gone deep into this example, but remember that example right there? This was 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus ... that right there. This does not become infinite. It just goes back and forth between 0 and 1. This diverges because it's not going to a single number. But divergence here doesn't mean infinite. It just means not convergence. Make sense? So all we have to say is diverges. That's it. Yes?
On the exam, can you skip the part you skipped where it's a
Yes, you can do this on the exam. That'll be on the final though, right? By the time we get to this, it'll be on the final. It won't be on this exam that we're doing. Yeah. The stuff today is not on your exam on Wednesday. I am going to ask you for convergence and divergence on the exam on Wednesday, but of sequences, not of series. And that's, to do a convergence of a sequence, all you have to do is take the limit as n goes to infinity. So yeah, okay, I guess, okay, you know what, you're right. Yes, you can do this on the exam on Wednesday. Yeah, because I'm going to ask you for convergence of a sequence, and you might use L'Hopital, and you do not have to switch it to x and go back. Is that what you were asking?
Yes.
Okay. Okay, for B, all right, sum n equals 1 to infinity of sine n. I want to show y'all something. I'm going to go to Desmos, all right? You all know how to graph something in Desmos, right? Everyone has seen me do it. How do you graph a sequence? How do you graph a sequence? There's a way to do it. It's pretty cool, so I want to show it to you. It's pretty easy. Okay, so first what I'm going to do is I'm going to type in y equals sine x. I have to type equal, not minus. Okay, so there's your sine function, right? And let me make this orange and somewhat transparent. And there we go. All right, so that's the sine function, right? So now what I'm going to do is I'm going to create a list of numbers. I'm going to put, they usually like it when you put capital K, and then I'm put equals bracket, and I'm going to go 1, comma 2, comma 3, comma 4, comma, if you put dot, 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 comma 100, it knows that you meant 1 through 100. Do you see where it says 100 elements in this list? And now what I'm going to do is just type in what do we want to do here? Sine of K? Right? Sine K, oops, capital K. I'm going to have it do it this way. There we go. So I have it, what I'm having it do is plot a bunch of points where my first coordinate is K, and then the output is sine of K. And that's what you get. Make sense? If I wanted to do like another sequence, K capital 1 over K, That's 1 over n, basically. That's like 1 over n. Okay, so I just want to show you that. Now, the reason I wanted to show you that is because I want you to see what happens if I take the sine curve out of there and I show you the sequence. That's basically sine of n, right? That's sine of n. What most people think happens with that sequence, most people think that this sequence, when you plug in 1, they think, okay, I get a positive number, and then next time I'll have a negative, and then a positive, and then a negative, that it switches. That's not the case. Look at the first 3 terms of this sequence. This is sine of n. The first 3 terms are what? Positive, and then negative, then positive, then negative. See? So they are following the sine curve, but it's not an alternating sequence. It's not positive, negative, positive, negative, positive, negative, right? Okay, let's get back to this. So I have the n-term test, right? N-term. I'm just going to put n-term now. So now what I do is I take the limit as n goes to infinity of sine n. And what can you tell me about that? What is it not? It's not converging to 0, right? This is not going to 0. What does it do? Well, look at what is that sequence doing? It's all over the place, right? Is it headed to one thing? Is it headed to 0? Hell no. So it's not 0, so we're done, right? We're done. Therefore, the original series. See, there's no work that I really have to show for that. I just have to know that that's not 0.
So if the original function is oscillating, then it's divergent?
Yeah, if it doesn't head to a number, then it's definitely divergent. If the original sequence, right, if this sequence right here, if it's oscillating, then for sure, oscillating without, you can have oscillation. Like if I change this, what if I did this? What if I put sine n over n? That does oscillate, but it heads to 0. Because here you have bounded over infinity. When you take the limit, right, imagine there, you would have bounded on top, right, over infinity. That would go to 0, wouldn't it?
Yeah.
And what would our conclusion be if it did go to 0? Therefore, the original series, no, I don't know. I don't know. Remember, this is the thing that gets everyone. The test for divergence only tests for divergence. You should never draw a conclusion of convergence with this test, ever. It only will ever tell you if you're divergent. That's it.
Can we keep that on our calculators?
Yeah, I think there's a way, but I don't know exactly. I haven't done this sequence in a long time. I'm sure there's a way. Google it. Does anyone know how to plot a sequence on your graphing calculators? You know how I showed you the modes, function, para? I believe there's a mode called SEQ, sequence, and I believe that switches it over to a sequence. So it knows that the input should only be like 1, 2, 3, 4. All right, last one. Last example. All right, this always gets everybody. Not everybody, it gets a lot of people. C. Tan inverse n. So I'm going to do the n-term test again, right? So I'm going to take the limit as n goes to infinity of inverse tangent of n. And that, I think we've talked about this a few times. What do you get here? What's inverse tangent of infinity? So think about your tangent function, the graph. Where does the tangent graph go to infinity? You know what tangent function looks like, right? Like this? At pi over 2. So this is headed towards pi over 2, which is not 0. Therefore, the original series diverges. So basically, the divergence test requires that we know how to find out. The divergence test has us look at the sequence and figure out if it converges to 0 or not. And we're hoping for something other than 0, right? Something other than 0, we can draw a conclusion. If it is 0, move on. All right, so now, what do you think? Understand the test? Feel like you get it? All right, so now what we do is we start looking at other series. And it turns out that, I mean, there's an infinite number of series, right? I mean, there's just like functions. There's an infinite number of these things. And so figuring out if they converge or diverge is going to be hard unless this n-term test works. So instead of going to starting to throw arbitrary series up here, we want to look at the classic ones. We want to look at the ones that we can actually get an answer for. All right? And the first one is called the geometric series. It's one of the most important series in all of mathematics. So we're going to take a first look at the geometric series here. And the way I'm going to try and motivate this idea is visually. So what you're looking at there is a square, a 1 by 1 square. And what I'm going to do is I'm going to ask you to shade half of that square and then tell me what the area is. All right? So I have this 1 by 1 square. It's 1 by 1. So shade half of it. Right? Take half the square and shade it. I forget which way I did it on there. Let's do it. Okay, I did the left half. Okay, so I take that, I shade it. What's the area of that? Half. Okay, so that's half. Plus, now what I'd like for you to do is shade half of what's left over. So shade half of what's left. So shade this. Okay, that bottom half right there. This almost looks like a little Texas flag. Okay, shade that. So how much do you have total now? 1/2 plus 1/4. Right? And now do it again. So far, what does that add up to be? This is 0.5 plus 0.25. So far, we have 0.75. Do y'all see right there I have it being added right there? Y'all see it? Okay, I'm going to keep going. Man, I need that to be in a different position. So now I've added half of that half. Now do y'all see it's 1/2 plus 1/4 plus 1 what? 1/8, right? And what we can notice is that each of these are just a power of 1/2. This is 1/2 to the first